Today we continue the ROM speed, size, capacity. Now we move for a MOS-ROM. MOS-ROM is nothing but it is a type of permanent memory that is programmed only once during the manufacture of chip itself. The data stored in it cannot be changed or erased later. This makes it highly reliable for the device that need fixed unchanging instruction. Why is it called MOS-ROM? During chip manufacturing, a special template called a photoglyphic mask is created. The mask defines which bit will be ones or zeros inside the ROM. Once the mask is created, the chip is produced exactly with those data values, hence the name MOS-ROM. Here some key features are there: programmed during chip manufacturing, fast read access, lower cost per bit, high NRE. Some examples are also there: old game cartridge, basic calculator firmware, fixed embedded system code. In this fixed embedded system code, we use digital watches, remote controls, early mobile phones, microwave oven controllers, simple toys. And this basic calculator firmware, simple calculators do not need any software updates. Their logic and arithmetic program is stored permanently in MOS-ROM. Early Nintendo and Sega cartridge stored games programs in MOS-ROM. The data was fixed and could not be hacked or changed. These are the examples of MOS-ROM. And then we move for next slide. This is a diagram of MROM. We clearly explain. It shows the internal structure of MOS-ROM, a type of read-only memory whose contents are permanently written during the chip manufacturing process. It stores data in the form of fixed connection. It cannot be modified once created. N-bit address input is nothing but this is the input given to the RAM. If there are n address bits, the ROM can have 2 power n memory location. These address lines go into the decoder. Decoder is nothing but it converts the n-bit binary address into one of the 2 power n output lines. Only one line becomes active at a time. Think of it selecting one row in a table. If n is equal to 3, address ranges 0002 to 111, that is 0s to 1. 8 lines will be activated one at a time. 2 power n lines means word lines. These are the internal lines connected to the memory matrix. Each line corresponds to one memory word. In MOS-ROM, whether a line is connected or not is decided at the fabrication time. Then we move for the encoder, that is the output logic. The encoder converts the selected word lines bit pattern into D-bit output data. This output corresponds to the content stored at the particular ROM address. D-bit output. These are the data bits coming out from the ROM. For every input address, ROM returns exactly one fixed D-bit value. We given the n-bit address of the ROM and the decoder activates exactly one of the 2 power n word lines. The activate line selects a pre-wired bit pattern. The encoder or output logic sends this pattern to D-bit output bit. The data sent out is permanent, cannot be changed. Next we move for the difference. First, programmable read-only memory can the data once and it stays permanently. EPROM can erase and reprogram the data many times. And the basic principle is one time programmable, it is a reprogrammable, and once data is written, you cannot change or erase it, but data can be erased using UV light and written again. Used when data must stay fixed forever. Useful during development when updates are needed. Here the cost is inexpensive, costlier than PROM because it is simple one-time programmable because of additional circuitry and quartz windows of UV erasing. Storage endurance is nothing but high endurance. It's firmly programmed and stable for long life. Here low endurance compared to PROM. Repeated erasing, reprogramming reduces lifespan. Construction. Here construction is nothing but covered with plastic casing. No window, no programming required. EPROM is nothing but has a transparent quartz window on the top. UV light enters through the window to erase or store the data. Next we see the flash memory versus EEPROM. First we see flash memory. Just we see the difference of technology, speed, access type, cost and usage, cheaper, endurance, capacity, interface and examples. Like that EEPROM also technology, speed, access type, cost and usage, it's more expensive, endurance, capacity, interface and example. First shortly I tell, it is based on the NAND gates. Speed is write faster than EEPROM, read slower than EEPROM, erase faster. Access type is a sequential access. It is cheaper, used for program storage and data storage. like USB drive, SSD, memory card, mobile storage. Endurance is less and life cycle is more than EEPROM. Capacity is gigabyte. Interface is parallel interface, D0 to D7 and control lines. And EEPROM is based on NOT gate, store less data. Here write, read, erase is slower than flash, faster than flash, slower but byte-wise. Here access time is a random access. These are the things of differences. Thank you.